So open source development, this is, I think this is the only section where I talk about development stuff, and then we talk strategy and business and legal and so on. So best practices, this is actually a section that I wrote down, and it was actually hard to translate because I had to sit and think of a lot of different things we've done in the past from a development perspective and classify them and figuring out, what worked, what didn't, and so on. And I actually failed to introduce myself at the beginning. I actually started my career as a developer. So I didn't try, I haven't written kind of commercial or deployed code maybe in 8-9 years now, but for the first 12 or so years of my career, I was an engineer and I got involved with open source and so on. So this section actually brought up a lot of good and negative memories from my developer days. So I thought to classify the best practices in kind of the typical requirement, phases that a company goes through, from a requirement to design, implementation, integration, and maintenance, just to help kind of facilitate where things fit. But of course, open source is kind of continuous build, continuous integration, continuous development, so it's a lot more cyclic than an easy category like that. So in terms of requirements, and I apologize for repetition, because some best practice in one area is also a best practice somewhere else. Basically follow the discussions. A lot of the discussions happens online, on mailing list, IRC, Glitter, different things. And there are a lot of things you can actually learn by just subscribing and reading the mail. And this is my recommendation to all new engineers that joined my team in the past, where the first 2 months are kind of a write-off in a way on the time of the developer. Especially if they're not an open source developer, it's basically they're like fresh graduate or engineer that you're trying to introduce into a new project and have them work on it. Basically, I see the first 2 months as kind of onboarding period where the person learns about the project. And the best way to learn is to subscribe and just spend their time reading and seeing what's happening in the project. Experiment with the latest stable and experimental releases. As I mentioned in a previous slide, there's like the 6 months release, and then the daily release, and then the weekly, and so on. So basically, have them jump on the latest release and try to figure out what's being done there. Determine your interests, and find others who have the same interest as you. Okay? And if you want to implement something, a feature, even before you start writing code, just go to the mailing list and say, hello, my name is Ibrahim. I work for this company, and we're interested in your project, and we have a need to have better battery performance or a better memory management or whatever. And I'm thinking if anyone on this list find this as something interesting they would like to collaborate with. You'd be surprised. In some cases, maybe you're the only one who have that interest, but most likely than not, if you have that interest in the project, most likely many other people have, and they will reply, and then that's how you start. Okay. Propose new features. Yeah, signaling intent, I think I managed that, and kind of over-communicate. Sometimes you send an email, you don't get a reply, and then you're like, nobody replied. So, people get a lot of emails. Some mailing lists are like hundreds of emails every day. So, when you have that situation, kind of reply again. Hey, I sent this email, a week ago and I haven't got any reply. Before I start working, I would like to see if anybody else is interested before I actually, start doing all this. And, of course, if you get people coming in and say, hey, I think I have the same interest, and then take whatever feedback there was, and you have a small team now. It's yourself plus somebody else, maybe other people, and then you can start working on it. Getting buy-in for new feature requests. This is especially important for kind of complex implementation, where you don't want to venture off creating and basically investing your engineers' time in developing something that may not be accepted in the future. So getting buy-in, basically getting the maintainers on the project and other developers saying, yeah, this is important, we need to do it, why don't you go start working on it? Then this is like really the best possible outcome that can come in from such conversation, where people think on the project that what you're trying to do is useful, it will benefit them as well, and they're willing at least to review your work if there hasn't been any people coming to co-collaborate with you on it. The typical feature request, if you want to request a feature, it's very different. I mean, of course, every project is different, but basically, you signal your intent saying, I'm interested in this feature. Is there anyone else who cares about it? There's discussion happens on mailing list, on chat, depending on the project, Slack, IRC, others. And then feature request is accepted. This is my own language to say, people believe that the feature you're asking for is useful, and maybe you have a volunteers to work on it. And then it's a tracked. It's similar as internal development. There's tracking. Different projects use different tools. Whether it's Jira or other open source tooling. And then when work gets kind of kicked off and there's progress, then that feature is prioritized and basically aligned with the future release. Basically, there's a tentative date for it. Okay, you need to get it done for this feature to be included in release X on this date. Okay, so then you're working towards an end date for it. And then, of course, development and testing is kind of an integrated process. And most projects work on that process. Okay, and they may use different tooling. Some projects use one tool to do this, other projects use others, or it's on mailing list versus it's on chat or whatnot. But this is kind of the main process. So the slides contain pretty much what happened in every step. I will just skip this for the sake of time, because I think it's pretty basic. Basically, for each section in the slides, you will see what happens in this phase and then what's the next step. But this is mostly development focused, so I'll kind of skip it. So mailing list etiquette. Okay, when I started my career as a developer, I made a lot of errors there. So this was actually a fun section to put together. So stay on topic. A lot of times you start an email. I'll give you a funny example, like, you're emailing your spouse, can you pick up the kids from school? And then it's that same email, the reply is, can you go to the store and buy something? And then, okay, are you picking up Chris from Taekwondo? So it's like the same email, but it's going in different directions. So we cannot do that in open source. Mailing list, you lose audience, okay? So stay on topic. So if you're talking about, memory management feature or, maintain this thread. If you want to then, if you have something else that came up on your mind, start a new thread instead of kind of moving with the older one. Don't use attachments. So when you want to send anything into mailing lists in open source projects, don't attach. And of course, this assumes that the project is using mailing lists. Some of them do, some of them don't. Some of them rely on GitHub issues. And different projects use different processes and different tools. Don't use the HTML email. This was a problem I personally had when I first started working for Ericsson. I was submitting patches and we used Outlook. And when you submit a patch with Outlook, Outlook changes the content of the patch in a way that introduces additional characters to it. And then when the maintainer receives the patch on the mailing list, the patch doesn't apply. And they're not going to investigate why it doesn't apply. They just email you, hey, this is failing, go do your job. Okay. So it confused some mail clients, and Outlook is the major offender there. And most companies use Outlook. Okay, so so make sure you have IMAP support and let your developer use other mail clients. Reply and forward messages using the inline. So this is a feature you can go to your mail client and configure it to use what's called kind of inline reply. Very simple stuff, but if you don't follow these, and I didn't, when I first started my career, either people would reply, hey, your stuff isn't working, or they just simply don't reply. Don't do capital letters. I didn't do this mistake, but it's considered like you're screaming at people. And the way you communicate is very important. Maintain it professional. Anyway, kind of stick to the technical stuff, right? A lot of people are international, so what is kind of socially acceptable in the U.S. may not be socially acceptable in Japan, or may not be socially acceptable in Europe. All this cultural stuff. So I don't know, basic stuff. Avoid sarcasm. A lot of jokes don't translate. So if I put a joke about a patch in the mailing list, people from the US will understand it. Everybody else will be upset with me. Okay, so avoid all that stuff. And not everyone is going to be professional with you on the mailing lists or with your developers. And basically, the advice to developers is if somebody doesn't treat you nice on the mailing list or says bad words, oh, this stuff is stupid, I don't know why you're writing this ugly code, just ignore that and just focus on the actual technical stuff. In terms of design, communicate early and often. We have the release early and often, and communicate early and often. Just keep people informed about what you're doing. Anticipate feedback. If people give you feedback, kind of reply, try to be very proactive with it. So you don't lose the interest of the people reviewing, and then they may not review in the future. Respond promptly, and really important in terms of design, plan for modularity. Think of scale. How can we, today you're only thinking about one thing, but you don't know what your needs are going to be in memory management in 5 years. So when you design your code, think of ways that you can make it future-proof in terms of taking it and scaling it to a different level. Recruit others. We all want to leverage engineering resources, so we need to figure out a way to go and get other people on the project to participate in helping us build what we're trying to build. I think I mentioned this. Don't be surprised if you have competitors who are interested in what you're doing and jumping in on it. In the early days of open source, of enterprise open source, in the early 2000s, I was part of a lot of discussions. Why do we need to contribute to a project that allows, back then it was like Nokia people to go, and I was at Ericsson, and Nokia and Ericsson were fierce competitors. There's so many people from Nokia on the mailing list that are using the project. There were like serious discussions on should we contribute something because it will get into the competition and use it. And over time we realized that actually this is all good and healthy because Nokia will contribute stuff as well, and there's Cisco contributing other things. So basically, and there was actually at one point we invited the VP from IBM, Dan Fry. I think he's retired now, to do a talk for us, and he had a very interesting chart where he showed a pie chart, and he showed that IBM contributes about 10% to that ecosystem. That was in the early 2000s. And the other 90% IBM uses from other contributions. Okay, so always have that in mind where you may be contributing and you want to go and recruit others, but your contribution is really a small part of the overall picture of what you're using. So there's a lot more benefits than what you're giving out. Design for acceptance. Remember that whatever your developers design has to go through peer review before it gets accepted. So you need to be aware of the acceptance designs and the various kind of criteria on which a project accepts contributions. Scope the design, subdivided. This is really important for large contributions and for contributions that touch on multiple subsystems. So if you're planning a contribution that will be kind of accepted in a single module, it's very different than planning a contribution that will touch on multiple modules, because multiple modules will be affected, so you have multiple maintainers to talk to, and you have to email different mailing lists and make sure all the maintainers are synced with you and the release management is aware, and but that's for large project. And be as non-intrusive as possible. So if you come in and you say, oh, I have this feature or this contribution, and it's going to go into the scheduler of the kernel. The scheduler is one of the most sensitive subsystems ever in the kernel, and it's going to take a really long time for you to get it accepted. So be aware of how intrusive is your contribution and make it kind of less intrusive to accelerate its adoption and its acceptance. In terms of implementations, kind of in open source, the division between kind of design and implementation is very blurry. Often, developers I talk to, they say, we design by just hacking basic code and sharing kind of initial coding bodies. But of course, it is expected that you will go through multiple iterations, and this is how open source improves. And don't expect perfections, and don't wait until the code is perfect to make it available. So always make it available as soon as something works, right? So that others can look at it and provide feedback. And this feedback loop is extremely important. Begin from a fresh pool. I was actually guilty of that a few times where my patches were rejected just because when I got the initial pool from open source, I worked on it and then I produced a patch, but then by the time my patch is ready, the upstream was different and my patch wouldn't apply. So you need to make sure your developers are kind of educated on this, and whatever they contribute needs to apply to the latest upstream version. These slides have a lot of information. I'm not going to read all of them, so I'm kind of walking you through it. Implement functionality in the smallest chunks. This is kind of counterintuitive to how companies work. But over the years, as you look back at a lot of the other companies who started in open source, 20 years before and have been gone, this is actually a great practice they even use internally. If you submit small piece of code, you're going to get better feedback on it because people will be able to read it and understand it. They will be able to test it a lot better than testing large quotes. And in general, it will result in better and more scalable code if you do things in chunks. Okay. So if you have big contribution, make sure to figure out a submission strategy that allows you to take kind of a big contribution and send it in small chunks. And of course, always think, assume if you are the maintainer and you receive 10,000 lines of code, and that maintainer receives thousands of lines of code from many people, right? So we need to make their life a little bit easier. Oops. Reusing code reuse is very acceptable. If there's any way you can take a shortcut by using existing code, whether it's open source or coming from other sources, and you can do that, go for it. There are a lot of benefits to reusing code. It's been already vetted and accepted. It's been tested. People are familiar with it. So it actually provides a lot of benefit to do so. And this is something we will mention in the inner source kind of presentation. And basically the premise of inner source is looking at open source practices that help kind of create better software. What kind of practices can we bring from open source and adopt it inside our company's development practices to improve our internal practices, right? And this is the whole premise of open source. Respect coding style. I think I mentioned coding style a couple of times before. Every project is different. Some of them even, you go to their website or to their GitHub repo and they have a section or a file that explains the coding style, and you have to respect that. And a lot of projects have actually tooling to verify if you're following the code style or not. There are basic tools you run against the patch or against the what you developed, and it will tell you where it breaks, what you need to fix. And all of that is part of building the knowledge about the project. When your developers join the project, these are the things they need to learn in the first couple of months before they start contributing code. So when to start submitting code for review, it works well, it compiles, it builds, it runs, it builds against the latest patch. You don't create security vulnerability, and you follow the coding patch. And it's small enough that it can be reviewed and tested by others. And of course, you can take this and add your own criteria and make it kind of internal policy to developers. Hey, don't submit anything until or unless it builds, it compiles against the or it applies to the latest upstream version. You check the coding style, and you're not creating any security hazards or security issues. And then once all of that is done, then you have the permission to go submit it. And one of the bad stories I would share, actually, it's a good time to say it now, was, I'm not going to say the name of the company, but I worked in a company where the code that was going from our engineers to the upstream, to one very specific upstream project, was so bad that the project stopped accepting any code from us. And it wasn't from my engineers, because my engineers are specifically hired to work on open source. It's from different product teams. And I received an email as the head of open source from that project community saying, you got to go fix this because your engineers are creating such bad code that it's consuming so much of our cycles. And you need to better follow the processes we have. Okay, and we were out for about maybe 2 weeks without access to submission until I confirmed back, okay, we're dealing with this, please allow us. And what we did is we created kind of a structure where junior developers don't submit directly. They have to submit the code to a more senior open source developers on my team to do the first review. And then once my team approves the patch, then the junior developer sends it to the mailing list. Okay, so if you don't submit code, or if you submit bad code consistently, bad code for a while, you'll be cut off. And we went through that. Some sign that your code is not ready: if it creates security vulnerability, it doesn't compile, that's a given. It doesn't meet coding style, and so on. And as I mentioned, you can create internal rules and have your developer follow it, and you're not gonna have any of these problems. We talked about patch submission process. So patches submitted. Of course, if you submit a patch over a mailing list, it's different than how you submit a patch over GitHub. It's different than other places. But look at this from in spirit, right? What the patch should do. It should create certain functionality or fix a certain problem. It should be offset from the main version. It must apply cleanly, not create any problems when it's applying. And it should do one thing, and it should do it really well. If you want to fix a problem, fix that problem or that bug and fix it really well. Don't fix that problem and then create others, or fix that problem and fix something else. That means you need 2 patches, not 1. Right? That's what I mean by kind of do one thing and kind of have a strategy for your submissions. Submissions, one patch that fixes multiple things in different areas will not be welcomed as just one patch that fixes one very specific things. So be as granular as possible. Be patient and persistent. It's a process. You submit, you get feedback, you resubmit, you get feedback. It works, you go open champagne. You're done, right? So that's kind of the process. Responding to feedback, in some cases, you'll get a lot of feedback, especially if it's a really interesting feature where different people have interest in it. So feedback may come in short, small bursts. It may be, this is great, you need to fix this. Okay. Or, oh, this code sucks. Oh my God, what were you thinking? That kind of feedback. Not very common, but it happens. So don't take it personally. Don't feel that your career is over or your engineer's career is over because they got bad feedback. Just kind of fix it and life goes on. And work with the community. Really, the whole part of being an open source project is to be part of that kind of growing community and help it grow with your contribution. So you want to be considered part of it, and responding to feedback is one way to do so. What if my patch is rejected? It's not the end of the world. People's patches are rejected thousands of times on a daily basis. Okay. it can be rejected for poor quality, not good functionality. It's inconsistent with the broader strategy of the project, or and a lot of these problems can be easily solved just by having the insight into the project, the tooling, and so on. So revise and work it again. And I think reasonable developers would understand. It's kind of different from working internally, because when you work internally, developers are not necessarily sharing their code with everybody within the department until they personally feel that it's ready. But in open source, you have to share as soon as you have something going, so you get feedback to make sure that it's approved at a later point for acceptance. Sometimes you may not get a reply, okay? And it happens. Maintainers have hundreds, thousands of emails every day, and they're humans. They have families, and we need to be conscious of that. And if you don't receive an answer, you can reply, say, I haven't received anything in a few days. I was wondering if you have some time to review those, and take it from there. And in 99.99% of the time, you'll get a reply saying, I'm so sorry, I got swamped. I'm just going to look at it in the next 2 days or something like that. So check this before submitting. So one of the things I would recommend is to create this checklist. I love sticky notes and checklists myself. I have checklists for everything. Before I fly, I need to have all of this and this and this. So checklist for developers is actually pretty useful. It's just to build good behavior. And after a while, they don't need to checklist anymore, because kind of it's the behavior is embodied in how they work. So tell the developers, before you submit, make sure that you follow the coding style, make sure it works, it builds it, all the different conditions. And after a month or two of following the checklist, the developer it will become a kind of automatic behavior for them. And it's not a checklist anymore. It's just things we need to do no matter what. Reporting bugs, of course, part of the contribution is reporting stuff. Source code contribution is a contribution to improve documentation is a contribution, but also a contribution is, hey, I found a bug. Who can help fix it? Without you actually fixing it yourself. So always search if there are duplicates. A lot of times people file, other than you, they would file reports, and if you experience a bug, you search the system for similar bugs. Maybe you can reconfirm, hey, I experienced this as well. If it doesn't exist, then you file it yourself. And file bugs for separate issues. So a bug that says, hey, I was building this thing and I experienced these 3 bugs. It's not going to work well, because if the 3 bugs fall in different subsystems, you're not getting the attention of everybody who needs to help fix it. You're getting only one person. All right, so in terms of testing, testing is continuous, same as development. So there's some basic QA for code. A lot of projects provide tools for that. A lot of the project will, you can go to their website or GitHub or wherever they keep their tooling, and they will provide you basic tools that you can apply on the code before you submit it. And the whole reason is to kind of minimize the overhead on the maintainer and try to offset a lot of the testing done by the maintainer and push it to the developers. So your developers contributing to a given project may have all the tools already to check for everything I already said with like 2 clicks on their keyboard before they submit code. So a lot of tools like GitHub, they have that continuous testing, and you can integrate that as part of the developer workflow. And one of the things I would also recommend is kind of identify the projects you want to work with and study the workflow of the developers, how development happens, and figure out what the developer on your team need to have on their workstation so that they're fully empowered to go through that workflow without kind of any glitch, right? And that they have all the tools they need. And this is part of kind of the onboarding that I mentioned, where like the first 2 months is just like learning, setting up your environment, learning the code itself, how the community works, and so on. And a lot of projects actually have their own test suites. So instead of submitting to GitHub and going through the GitHub integration, you can actually have those tools locally on your computer. which kind of shortcuts a lot of the testing. In terms of maintenance, don't dump and run. In the early days, a lot of companies were like, hey, here's 50,000 lines of code to this project, and then they disappear. Okay, a company that provides code but doesn't stand by the code to help, fix it and make it up for integration, all of this will be abundant. If you're submitting code and there's a problem with it, it's totally fine. You can make a patch and say, hey, this functionality does A, B, and C, but I'm aware I have this problem and I'm unable to solve it. Can somebody please advise me on it? And this is totally fine. Actually, pretending that there's no problem and, oh, I didn't know that, it's just going to fire back and people will not like it. And of course, in some cases, you may deliver code and just, you may not have the resources to maintain it. And that's fine. You can say, I have this useful functionality for the project, but I cannot commit some money, either myself or somebody from my company to continue maintaining it. And people will step up and volunteer themselves to maintain it. And if you're the maintainer for that case, and that's your initial contribution, you may have people submitting code to it. And if your code, and now you're like the maintainer for it, okay? So when people submit it, don't consider the code as quote unquote like your baby now and you need to protect it. The whole idea is to get people to contribute. So, keep that in mind and accept people's contributions. So I think that's the end of the section. And these were by the way, the hardest two sections for me to present just because they're like just coding stuff. And I think the fun decks are coming up. So maybe we take a few minutes break. And if you have any questions, maybe we can do questions now. And by the way, you are completely free. These decks, we made them available under CC by 4, which is basically a license that allows you to take that code, the slides, copy them, change them, do anything you want with them, okay? You can modify them, do internal training with it, it doesn't matter. So, and if you have any questions, we can take it now.
So, before everybody wants to take a break for a couple minutes, is there a question? Frank?
You mentioned all the. I'm Frank from Locomation, Netherlands. You mentioned all the cycles, but our team works in Agile Scrum cycles of 3 weeks. How is this? Can this be aligned, or how does it work? What's your experience?
Yeah. So there's always two paths. There's what's happening inside the company. And of course, you're working towards either building a service or a product. And you have your own methodology of doing things. And you have what's happening in the open source part. And, the whole key, you can be doing anything you want on this side. And I think, but I think what's really important is to maintain synchronity across these two paths. And align your internal efforts with what's happening in the project, because you cannot control what's happening on the open source part, but you control what's happening in here. So you don't want your 3-week cycle to be 2 weeks behind the release cycle of the projects, for example. You want it to be before, so that when you're done with your cycle, you dump it here and then it gets integrated there. So my thought on this is just, and every open source project is different. So, and you cannot adjust your internal development to like 50 projects you're using. So my thought is to identify the critical 3, 4, 5 projects that you rely on in your internal development and synchronize your internal cycle to follow the external cycle of the open source. And in some cases, it can get very complex. And I'll give you an example, okay? So I was working in a company in the past, and we launched an open source project with another company. Okay, so internally to our company, we had our own, Git repos and cycle. The other company who was our partner, they had also their own cycles, and we also had the open source cycles. And now, and of course, we were the founders of the project, but there were other companies as well. So now I have a developer on my team who's working on the internal cycle, but also needs to contribute to the open source cycle, and in some cases, contribute to the other companies. Okay, so you can see. So it can get very complex. And we actually had whole day meetings in many times to figure out a way that we can think this. So it's if it's just your company and a couple projects, it's easy. It can get hard, but it's not undoable. It's not impossible, right? It takes more planning. And there's like there will be 2, 3, 4 weeks of transition where you're not following the normal process internally to the company, but then once you lock in the new schedule and you become synchronized to the project, then your life and the life of your engineers will be a lot simpler, because then you can do your internal sprint and then take the output, submit it as a patch there to the to the open source projects, and then you stop that here, and then you follow on the internal on the external open source path.
Other questions?
So after the break, we'll talk about open source program offices, and this is actually from here on, it's going to be a little bit more fun presentation. So please come back.
So I want to just add a couple of things. So one of the things that I recognize is that you all don't know each other, and our names are really small. So if you want, you can take a marker and make your name bigger, so that, at least for me, I'm like going up like this. Because I also know that there are members of companies who are here who have other team members from other parts of the company that don't even know each other. I won't actually call out which company I know that is true for, but I'm hoping that EnergyNet will get to know each other. And maybe there's some others there that also have that problem. Out front, FOSS-ID was really generous in helping us to print some of the material that Ibrahim has done. So what you'll find out there is 2 books. Please take it, and also a LF Energy battery power pack. And those are our gifts to you. Please take those books and use them and read them and look at them and share them with your colleagues. The PDF versions are available online as well. But the print versions I think are really great to look at. And they did a great job. So thank you very much for contributing that and for contributing your great intellectual property.
So one note about the books I'd like to mention is, so we have Japanese translation done by random people, companies in the Linux Foundation, and we also have a Korean translation being done. So if for some reason you want to translate it to Dutch, to French, feel free. You don't need to email and ask permission. It's all open. You can take it, and if you find pieces that are important to your companies, you want to translate it to your local language and share it, you have the approval to do so. Right?
The other thing I wanted to add is that I know that many of you are working on different projects. I was talking to somebody yesterday who was talking about, an architecture that he was doing for something that I know somebody else is also doing. At some point, what I would like to do maybe this afternoon is we're going to talk about the LF Energy architecture and have Benoit and Arhan kind of go through that with everybody, talk about the projects that we have going, some of the special interest groups. But I also really want to give people the time to stand up and say, I'm working on, an architecture, an IoT architecture, let's say, for instance. I think that there are probably 5 or 6 companies represented here who have architects in this room who are working on the exact same thing. I would really like it when you leave today that you have each other's information, because it will go much faster and you will be able to spend time with your families and do all kinds of things, maybe go on vacation, things that you maybe wouldn't be doing if you were doing it alone. Okay, let's take a break.